In this video, we are going to talk about reaction of halide ions with concentrated sulfuric acid. Now, the halide ions we'll be looking at include chloride, Cl minus, bromide, Br minus, and iodide. I minus. All right. Now, these reactions will lead to the formation of hydrogen halide gas. Okay. So we basically use this to prepare hydrogen halide gas. But the question is, which halide gas can we get in the purest form if we use this method? All right, so let's take a look at the reactions. Now, in the first place, you need to take note that this reaction produces gases that are toxic. So if you are going to carry out this experiment in the lab, you need to do it in the fume chamber. So consider a reaction between sodium chloride and sulfuric acid, H2SO4, liquid. Now I'm using liquid because it is concentrated sulfuric acid. What is going to be the product of this reaction? We're going to have sodium hydrogen sulfate, solid, and then you have HCl gas, right? So solid sodium chloride, liquid hydrogen sulfate or sulfuric acid, then you're going to have sodium hydrogen sulfate and hydrochloric acid gas. Now, are we going to have any observation in this reaction? Yes, you'll notice a white fume, but that white fume is hydrochloric acid in the gaseous form. So white fume. So that is what you observe for hydrochloric acid. Now, what you need to know is that we cannot use the same process to make hydrogen bromide gas. So remember, in this reaction, we have HCl. For the chloride, we are going to have HBr for bromide, and we'll have hydrogen iodide for the iodide. Now, we cannot use this process to make a pure HBr and HI. I'm going to tell you why. What happened is that the decomposition of hydrogen halide increases down the group. Now, why is that so? Remember that as you go down the group, the bond length between the hydrogen and the halide ion increases. So you have HCl. HCl will have a shorter bond length compared to HBr, which would have a shorter bond length compared to HI. Now, why is that so? As you go down the group, you have new shells that are being added to the halogen, which means that there is an increased distance between the outermost shell and the nucleus of the halogen. So the shorter the bond, the stronger it is. Then the longer the bond, the weaker it gets. So what happens if this bond breaks? Now, when this bond decomposes, when the HBr decomposes, you have the halide ion getting oxidized. So that is exactly the reason why we can't have a pure HBr gas or HI gas when we react the hydrogen halide, the halide ion with concentrated sulfuric acid. Now you need to note that The sulfuric acid, which is H2SO4, is quite a strong oxidizing agent. Now, you should also know that the H2SO4 is not strong enough to oxidize hydrochloric acid. Now, I want us to take a look at sodium bromide reacting with sulfuric acid. The first thing that happens is that you have the sodium bromide, NaBr, solid, reacting with H2SO4 concentrated. So I'm going to make it liquid. And we are going to have sodium hydrogen sulfate. And then we'll have HBr gas. So this is what happened in the initial stage. So we are going to have the HBr gas in the initial stage, but remember that hydrogen bromide is easily decomposed. So what happened next is that we are going to have the HBr reacting with the sulfuric acid. So, so we have HBr plus sulfuric acid, H2SO4. Br2 is going to have oxidation state of 0. That means that it is moving from -1 to 0. That is oxidation. All right. Now we have Br2, and then we also have sulfur dioxide. Remember that as the sulfuric acid is oxidizing the halide ion, it gets reduced by itself. So we're going to have SO2 gas as well as water, H2O. So to balance this, I'm going to put 2 here and 2 here as well. So this is the reason why we cannot make HBr gas using concentrated sulfuric acid and bromide salt. Okay? Because you have the bromide, the, the hydrogen halide gas reacting with the sulfuric acid and getting oxidized to a halogen. Is there any specific observation that we are going to make in this particular reaction? Yes, you'll notice that you are going to have a reddish brown gas. Now, this color is as a result of bromine Br2 getting formed. So, bromine will give you a reddish brown gas. So, that observation is an indication that you are not getting a pure HBr gas, rather, you are having a bromine gas coming out of the reaction. Now, let's look at what happens if we react sodium iodide, NaI, with sulfuric acid. Now, you need to know that the sulfuric acid will get reduced to several different sulfur products. Okay, so H2SO4. So, what is the first reaction that takes place? Because we have the sodium iodide solid reacting with the sulfuric acid. Then we have sodium hydrogen sulfate. Then we have hydrogen iodide. But then you know that this hydrogen iodide gas is not going to be stable. It's not going to be stable because we are going to have it oxidized. So the next thing that is going to happen is oxidation of the hydrogen iodide. So we are going to have three separate reactions there. In the first place, we are going to have hydrogen iodide undergoing a reaction with sulfuric acid. Then we'll have I2. Then we'll have SO2, sulfur dioxide. And then we also get water. So to balance this, I'm going to put 2 here, and I'm also going to put 2 here. Now, what is going to be the observation in this reaction? We are going to notice a purple vapor, okay? Purple vapor. Now, purple vapor is an indication that you are having iodine gas coming out from the reaction. In the second reaction, again, we'll have hydrogen iodide reacting with sulfuric acid. And this one is going to give us iodine. But then we are going to see the yellow crystal, which is going to be sulfur. And then we'll have water. So to balance this, I'm going to put 4 here. Then I'll have 3 here. And then over here, I'm going to put 6. All right. So the observation here is yellow crystal or yellow solid, which is an indication that sulfate anion gets reduced to sulfur. And the last reaction to take note of is we're going to have again the hydrogen iodide with sulfuric acid H2SO4. And this time we're going to have iodine, and then we'll have hydrogen sulfide H2S. Then we'll have water. So to balance this, I'm going to put 4 here. And then over here, I'm going to have 4 moles of iodine. And here, I'm going to put 8 to make it balanced. So what is the observation that we are going to have if this reaction is occurring? Now, what is going to happen is that you have the hydrogen sulfide gas giving you a rotten egg smell. So if you have a rotten egg smell, you begin to see yellow solid crystals and you have a purple vapor coming out. That is an indication that you are not getting hydrogen iodide gas, but then it is getting oxidized to iodine, and the sulfate is being reduced to sulfur or hydrogen sulfide. Now, these are the reactions that take place if you have sodium iodide reacting with concentrated sulfuric acid. And you are supposed to know these reactions as it is stated in your syllabus. So we are going to conclude that it is easier to oxidize hydrogen halides as you get down the group.